Hello everyone. Today we will study the series RLC circuit. At first we will design a series RLC circuit, and then we will supply voltage and we will measure the voltage across the resistor, capacitor and inductor by our voltmeter, and then we will measure current by ammeter, and we will check it in oscilloscope. Okay, so we see a simple series RLC circuit here. So voltage supply to resistor to inductor to 1 microfarad. So in this experiment we will use decade box for resistor. This is resistance decade box, this is inductance decade box, and this is capacitance decade box. So we see here 3 pins, so we will use these two. This one is entering, this one is leaving. Okay, this one is entering, this one is leaving. So the red one is entering, the black one is leaving. Okay, so what we see, the voltage supply positive part is going to resistor. So the positive, so this is our function generator. Okay, this is the positive part of function generator, and it goes to a resistor. So this is the resistance decade box, so enters the resistor and leaving from the resistor to the first part of inductor. So this is leaving from here and going to the first part of inductor. Okay, and then the inductor second part is going to the capacitor positive part. So inductor second part, that means black one, is going to the positive or the first part of our capacitor, and the capacitor second part is going to negative of voltage supply. So this capacitor's negative part is going to the negative of our voltage supply. Okay, so the connection is done. Now we will give voltage supply from this function generator, and we will select the frequency 1 kilohertz. So it's 1 kilohertz now, and our circuit is now completed. Now we will check the voltage of the supply by our voltmeter. We are going to use this multimeter as voltmeter or ammeter. So let us measure the voltage supplied from this function generator. So for measuring the voltage, we have 2 points of the function generator, positive and negative. We have added our multimeters two part, the red one and the black one. So positive one connected to positive of our function generator, and this one is connected to negative of our function generator. So what we get here is 6.3 volt. This is an RMS value, and we will write it down. So our voltage supplied is 6.3 volt RMS, and the function we see is 1 kilohertz. Okay, is 1 kilohertz. Now we will measure the current. So for measuring the current, what we want to do is we will put the ammeter in this point somewhere. So the voltage supply positive part and the resistors first part, we will disconnect this and put the ammeter here. So we have done this here. The positive part of voltmeter is removed from the resistors connection, and we have put the positive of ammeter and the negative of ammeter in between these open point. Okay, so what we find is 20.03 milliamps. We will write 20 milliamps. Okay, so now we will measure the voltage across the resistor, voltage across the inductor, and voltage across the capacitor. To measure the voltage across the resistor, we will put the 2 points of our voltmeter in the two points of the resistor. So what we see, that we have put 1 point here and another point here. That means we will measure the voltage in parallel point. Okay, put the points here, and we see the value is 1.977 volt. Okay, so here is 1.977 volt. In the similar way, we will measure the voltage across inductor. So what we get is 8.52 volt. Okay, same for the capacitor. So what we do is we are measuring the 2 points of the capacitor, and we get the voltage. So we find 2.99 volt, that means 3 volt. Okay, that means 3 volt. Okay, I have forgotten to mention one thing. So how did we put the values here? We see resistance 100 ohm, inductance 65 millihenry, and capacitor 1 microfarad. So here we see 2 points out and in. So if we put any point down, we it means the this value is activated here. So we needed 100 ohm, so we have put down the 100 ohm key down, that means it is in input. Okay, so 100 ohm is active and all the other switches are off. Okay, same way here we needed 65 millihenry. So what have we done? We don't get 65 millihenry directly. For that we will do 40 and 20, that adds 60, and 2 and 3 sums 65. So we will put these keys down, that will sum up to 65 millihenry. And same goes for the capacitor. 1 microfarad is available, so we have give that as input. Now we will see the values from our oscilloscope. So in oscilloscope channel 1 we will check the voltage supply. So we have taken the positive probe of our oscilloscope and connected it to the voltage supply. So what we did, the probes, this part is positive and we have connected it to the positive, and this is ground. Okay, now let us see what our oscilloscope shows. So we see that our channel 1 is active here. That means the channel 1 we see the function generator output. So this is a sine wave that we see. We can see our function here, function frequency. So the frequency is 1 kilohertz, you can see it here. And then we see the RMS value is 6.34 voltage. Okay, that we can see here. So we have got the voltage supplied by measurement is 6.37 volt. Now let us take the channel 2 of our oscilloscope. So we will take this probe and we will connect it to the resistor. So now from our oscilloscope's channel 2 we will see the voltage in oscilloscope. So we connected the probe in the positive and this is in negative part. So we see that the output is here. So the voltage across the resistor is 2.00 volt or 1.99. So we have got the voltage VR on a 1.977 volt. So now we have done two things: the yellow channel, that is our voltage source, and the blue channel, that is our resistors, voltage across resistor. So we see the phase angle is 0.2 degree or 0 degree. Then we will measure the same thing from the capacitor, from the inductor. So we have got the inductor value is 8.52 RMS. Now we see the RMS value is 8.43 volt, and we will see the volt phase angle now. So if we look now, we can see a different phase angles. So the phase angle is shown here 1 and 2, that is minus. Okay, the phase angle is clearly visible here, that is minus 17.6 degree. So we got it here, and now we will check about the capacitor. So we have put the probe here across the capacitor, and we see in the oscilloscope that there is a huge phase difference. The phase difference angle is 146, almost 146 degree. So we have seen the phase differences in our oscilloscope.